A-Level Geometric Progressions. An exercise on sums to infinity. The following is an exercise on sums to infinity of geometric progressions. Pause the video at this point and have a go at the questions. When you've finished, restart the video and I'll go through the answers. Okay, let's go through the questions. In question 1, we have to find the sum to infinity of the following geometric series. Now, in part 1, we have 75 plus 45 plus 27 plus 16 and 1/5, and so on to infinity. Now, to solve this, we've got the first term, a, is 75, and the common ratio is the second term divided by the first term. So that's 45 over 75, which is 3/5 or 0.6. Now the formula for the sum to infinity is a over 1 minus r. So a is 75 and r is 0.6, so that's 75 over 1 minus 0.6, or 75 over 0.4, which is 187.5. So that's our answer for the sum to infinity. In part 2, we've got the series 108, 36, 12, 4. Well, the first term a is 108, and the common ratio is 36 over 108, which is a third. So the sum to infinity is 108 over 1 minus a third, which is 108 over 2/3, or 108 times 3 over 2, which is 162. So the sum to infinity is 162. The third series is 0.1, 0.02, 0.004, 0.0008, and so on. Well, the first term is 0.1, and the common ratio is 0.02 over 0.1, which is 0.2. Now the sum to infinity is the first term over 1 minus the common ratio, so that's 0.1 over 1 minus 0.2, or 0.1 over 0.8, which is an eighth, or 0.125. So the sum to infinity is 0.125. In part 4, we've got the series 8 minus 4 plus 2 minus 1 plus a half, and so on. Now the first term is 8, and the common ratio is minus 4 over 8, which is minus 0.5. So the sum to infinity is 8 over 1 take away minus 0.5, which is 8 over 1 plus 0.5, or 8 over 1.5, which is 16 over 3, or 5 1/3. So the sum to infinity is 5 1/3. In question 2, the first three terms of a geometric series are 4x, 10, and x. Find the possible values of the sum to infinity. Well, the first three terms of a geometric progression are a, ar, and ar squared. So we have a equals 4x, ar equals 10, and ar squared equals x. Now if we multiply the first and the third term, that's a times ar squared, that's the same as the second term squared, ar all squared. So 4x times x equals 10 squared. 4x squared equals 100, so x squared is 25, and if we take the square root of both sides, we get x is equal to plus or minus 5. Now if x is equal to 5, 4x is equal to 20, so we have the series is 20 plus 10 plus 5 plus 2.5, and so on. So a is 20, and the common ratio is 10 over 20, which is 0.5. So the sum to infinity is 20 over 1 minus 0.5, which is 20 over 0.5, or 40. If x is equal to minus 5, then the series is 4x, which is minus 20, plus 10, minus 5, plus 2.5. So the first term a is minus 20, and the common ratio is 10 over minus 20, which is minus 0.5. So the sum to infinity, a over 1 minus r, is minus 20 over 1 take away minus 0.5, which is minus 20 over 1.5 or minus 40 over 3, which is equal to minus 13 1/3. So the sum to infinity is either 40 or minus 13 1/3. In question 3, we're given the sum of the first three terms of a geometric series is 18.5. The sum to infinity is 4 times the first term. Find the first term and the common ratio, and find the sum to infinity. Well, for part 1, we have the sum to infinity is 4 times t1. So a over 1 minus r is equal to 4a. We can multiply both sides by 1 minus r, so a is equal to 4a into 1 minus r, and we can divide both sides by a. So 1 equals 4 into 1 minus r. So 1 is equal to 4 minus 4r, or 4r equals 3, which means r is 3/4. Now we have a plus ar squared is equal to 18.5. We also have r is equal to 3/4, so if we substitute that in, we have a into 1 plus 3/4 plus 9 over 16 equals 18.5. Putting it over a common denominator, we have a into 16 plus 12 plus 9 all over 16 is equal to 18.5, or 37 over 16a equals 18.5, so a equals 18.5 times 16 over 37. Well, that cancels down to give a is equal to 8. So the first term is 8 and the common ratio is 3/4. Now we know the sum to infinity is 4 times the first term, so that's 4 times 8, which is 32, and so the sum to infinity is 32. Now in question 4, we're told the third term of a geometric series is 16, and the sum to infinity is 3 times the first term. Find the first term and the common ratio, and then find the sum to infinity. Well, to solve this, we have t3 is 16, and the sum to infinity is 3 times t1. Now the third term is 16, means ar squared equals 16, and the sum to infinity is 3 times the first term, means a over 1 minus r is equal to 3a. So if we consider a over 1 minus r equals 3a, we can divide both sides by a, so 1 over 1 minus r is equal to 3, or 1 equals 3 into 1 minus r. If we expand the brackets, that gives us 1 equals 3 minus 3r, which can be rearranged to give 3r equals 2, or r equals 2/3. Now we've got ar squared is equal to 16, so a times 2/3 squared equals 16, or a times 4/9 is equal to 16, so a is equal to 16 times 9 over 4, a is equal to 36. So we have the first term a is equal to 36, and the common ratio r is equal to 2/3. Now we know the sum to infinity is 3a, so the sum to infinity is 3 times 36, which is 108, and that's our answer. Now if we wanted to, we could check this. The terms are 36, 2/3 of 36, which is 24, 2/3 of 24 is 16, and so on. So the third term is in fact 16. And if we work out the sum to infinity, it's a over 1 minus r, which is 36 over 1 minus 2/3, or 36 divided by 1/3, which is 36 times 3, which is 108, which is in fact 3 times the first term. In question 5, we're given the geometric series t1 plus t2 plus t3 and so on has first term 5 and sum to infinity 3. A second geometric series is formed by taking every other term in the first series, that is t1 plus t3 plus t5 plus t7 and so on. Find the sum to infinity of the second series. Now we have in the first series t1 is equal to 5 and the sum to infinity is 3, which means a is equal to 5 and a over 1 minus r is equal to 3. Now that means 5 over 1 minus r is equal to 3, or 5 is equal to 3 into 1 minus r. If we expand the brackets, 5 is equal to 3 minus 3r, which means 3r is equal to minus 2, or r is equal to minus 2/3. So the first series is 5 minus 2/3 of 5 plus 4/9 of 5 minus 8/27 of 5 plus 16 over 81 times 5, and so on. Which means the second series is 5 plus 4/9 of 5 plus 16 over 81 times 5, and so on. So for the second series, a is equal to 5, and the common ratio is 4 over 9. Which means the sum to infinity is 5 over 1 minus 4 over 9, which is 5 divided by 5/9, or 5 times 9 over 5, which is equal to 9. So the sum to infinity of the second series is 9.